Hello everyone, and thank you for joining me. We're going to be doing the last of the series of lessons, Ways 2. Okay. And I'm going to conclude this last of the 4 operations with the standard division algorithm. I think it's fitting. Okay. This is otherwise known as long division. All right, let's get to it. The first thing I want to point out, okay, and I did this for my other video, ways to divide with the partial quotients, okay, is to just do a quick little review of how division looks, okay? It can look in many different ways. Okay, so I'm going to take something like this. It can look like this, 24 divided by 4. It can look like a fraction. Sometimes the fraction is written like this with a diagonal line. So it can look and express itself in many different ways. The most important part that you remember, okay, is what the numbers mean. 24 is called the dividend. Okay. 4 is called the divisor. Okay, just like a teacher teaches, the divisor divides. It divides the dividends into different parts. The answer of all of these problems, of course, is 6. 24 divided by 4 equals 6. Okay? And that has a special name too for a division problem. It's called the quotient. So 6 is called the quotient. Okay, in division, the quotient is the answer. Okay, so for addition and subtraction, we call an answer a sum. In multiplication, we call an answer a product. But in division, we call the answer a quotient. Okay. So let's go ahead and take a look at some examples of long division. And then we'll discuss the pros and the cons. What's good about it, what's maybe not so good about it, and see if it's for you. Okay. I'm going to take a, let's say 48 divided by, say, 4. Okay, if you looked and saw my other video on partial quotients, okay, we put all the partial quotients here on the right side of this symbol here, this division symbol. Okay, but with long division, we don't do that. Okay? Instead, we're going to divide inside of the dividend by 4, okay, by the divisor. Okay. So, I'm trying to find a number that would multiply well into 4. So basically, and this is what you want to think, is you're dividing digit by digit. Okay, so this is a little bit of a trick here with long division, digit by digit. Okay, so I know that 1 times 4 equals 4. When I subtract that, I get 0. Now, what we do with the next number is called dropping it down. So we're going to drop the 8 down, okay? Put it right there. Or, if you don't want to put it right there, you can just put it next to the 0. In fact, that might even be a better idea. Okay, so we're going to drop this 8 down here. The next thing I want to do is I want to figure out a number times 4 that equals 8. Okay, so I know that number is going to be 2. 2 times 4 equals 8. When I subtract this, I have no remainder. So I know that 48 divided by 4 equals 12. Okay? The total, of course, is going to be the quotient, which is actually the total amount at first, rather, the dividend is 48. And then we're going to divide it equally into 4 groups, and we're going to have 12 in each group. Okay? So if you saw my video on ways to think about multiplication and division, okay, I worked with what are called manipulatives, and I demonstrated with different types of beans and stuff like that. Okay, another way to think of this is that just conceptually, okay, if I had 48 of something and I broke them equally into 4 groups, okay, this is called a sharing mat. It's in that other video I have, okay? Then I'm going to have 12 in each group equally. Okay, that's called equal shares. There's another concept called equal parts, but for now this is good enough. If I have 48 and I'm putting them in 4 equal groups, I'll have 12 total at the end, okay? So that's long division. Now let's go ahead and work on some problems. Pencil and paper. Okay, let's just do number 1. Let's stick with our 1-digit number as a divisor, but let's do something more challenging. Let's say like 7. And we'll do like a 3-digit number. We'll say 384, something like that, okay? Now, the first thing I notice is that 7, I can't multiply a number times 7 that goes into 3, okay? My teacher used to teach us to put a 0 there. I'm not going to necessarily do that. But what you want to do is find a number that is closest to 38 without going over it. Because we can't multiply 7 and it goes over the number 3, okay? So I'm going to use 5. 5 times 7 is 35. 8 minus 5 is 3. Okay, drop the 4. 4 comes down. Okay. Now in this case, we're definitely going to have a remainder, I can tell, because there's no more numbers to drop, and no number times 7 actually equals 34. Okay, so I'm going to do the number 4. 4 times 7 equals 28. And then I have, okay, so I can use my bigger bottom, better borrow if I want to. 14 minus 8 is 6. I can't divide into 6, so that's my remainder. Remainder 6. Okay, in the partial quotients video, there is a way to check to see if it's correct. I don't recommend using a calculator because it'll give you a decimal rather than a remainder, okay, kids? So try to stay away from the calculator if you're using these division strategies. But there is a way you can check, okay? You're going to multiply the divisor times the quotient, and you're going to add the remainder to that. All right, so 7 times 54 plus 6. Okay, and this is known as multiple operations because you're multiplying and you're adding. Okay, now I put 5 there. I made a mistake. This is actually 54, of course. Precision, not perfection, right? Okay, so the next thing I'm going to do is I'm going to multiply this, and I love to use partial products for multiplication. So 7 times 50 is 350. 7 times 4 is 28. Okay, so 350 plus 28 is 378. And now I have to add that to 6. So now it's going to equal 384. 378 plus 6 equals 384. Now, this is going to be equal to my dividend. That's how you double check to see if that's correct. Okay. If you haven't seen my video on ways to multiply partial products, check it out. Okay, so now, let's up it up just a little bit. Let's crank it up a little bit. Let's give ourselves a 2-digit number, which is the divisor, and let's stick with the 3-digit dividends for now. So 529 or something like that. Okay. I can't divide 21 into 5, obviously, okay, but instead I can divide 21 into 52, and I want to figure out how many times I can, okay? So I like to skip count a lot. 21, 42, 63. Okay, so it seems like I went over a little bit there, right? 21, 42, 63. So that's too high. So I know that 21 times 2 is going to give me 42. Can't go over 52. I can't go over 52 if I'm looking at that. 52 minus 42 is 10. Now I drop my 9. So how many times does 21 go into 109? That's what you need to ask yourself now. Okay, I'm going to make a prediction of 5 because I know that 5 times 21 equals 105. 5 times 21 equals 105. Okay, now I have a remainder of 4. Or 4. Okay. So now what you do is double check 21 times 25 plus 4. Okay, so again, you're going to multiply your divisor times your quotient and add your remainder. Multiple operations problem. Okay. Now I don't want to have to sidetrack us right now by multiplying that with partial products. So I'm just going to use a calculator. 21 times 25 plus 4. And this should equal 529, which is our dividend. And there you go. Okay. Great way to check your work. Now, before we proceed, I just want to point something out, okay, is with long division, you're not really thinking about the place values. That's one of the big issues with long division, and that's one of the reasons why partial quotients is more popular nowadays. If you notice here, okay, I was describing this as 52 minus 42, but that's really not true. This is actually 529 minus 420. Okay, that would be more accurate to say. But when you're doing long division, you don't have to think of it like that. Okay, so long division, like a lot of the standard algorithms, are basically like a procedural way or a step-by-step way to solve a problem. Okay? It is possible, like I just demonstrated, for you to think about it by the place value, but it's not necessary. Okay. I want to do a one-digit number just because I'm having fun with this. I want to do a one-digit number divided by, say, a 5-digit number in the 10,000s. So I'll say, now you know what? I want something that I can divide the first number into. So we'll say 93,487. Doing these standard algorithms kind of takes me back to my childhood a little bit. Okay, as a teacher, I haven't really used these because they're not being taught. So standard division algorithm and standard multiplication algorithm are not really being taught in the schools anymore, as far as I know. Okay, they're shifted away from that. Now, standard addition algorithm and the standard subtraction algorithm are still in use, but not for division and multiplication. Okay, so my mind just sort of has to shift a little bit in order to get this, but it's fine. Okay, I remember what my teacher taught me from 4th grade back in, what was it, 1980, 84, something like that, 1985, okay? All right, so 8 goes into 9 once. 1 times 8, 8 is 8. Okay, 9 minus 8 is 1. We're going to drop our 3 down. Remember, digit by digit. 3 is here. Okay, what number times 8 is going to get me close to 13 without going over? Just another 8. Because 8 times 2 is 16. 1 times 8 is 8. 13 minus 8 is 5. It is fun to do, though, that's for sure. And you will get the right answer. Drop that 4 down. What number times 8 is going to get close to 54 without going over? Okay, 6. 6 times 8 is 48. And it is good reinforcement for your basic multiplication facts. Okay, if you need a multiplication chart like this, by all means use it, okay, as a reference. Okay. All right, moving on now. So I'm going to subtract this. Okay, bigger bottom, better borrow if you want to. I prefer to count up for subtraction. I know that 48 plus 6 equals 54, so that's 6. Digit by digit, I draw my 8. Okay, 8 times 8 equals 64. Subtract that and get a 4. Drop this 7. I already know that 6 times 8 is equal to 48. If I want to use my multiplication chart just to demonstrate, I can find that out. Okay, especially if you don't have all of your multiplication facts memorized, your basic facts, this is going to be really, really hard for you. So you need a reference guide, like a multiplication chart, and it's fine to have a reference guide. There's no problem at all until you memorize your basic facts. Memorizing your basic facts, this is your basic facts of a one-digit number times a one-digit number. Aside from the tens, that's not a basic fact here. Okay, but the other ones are one-digit number times one-digit number. Okay, so I'm looking at 8 times 6 again, and I see that's 48. All right, and that's going to be a little bit too high if you notice. So I'm going to use 5 instead. 5 times 8 is 40. 47 minus 40 is 7. Okay, that's your remainder there. You can't divide into it anymore. Remember that little trick I used from some of my other videos? A, B, C, comma. Okay, C begins with comma. So, I think that 93,487 divided by 8 equals 11,685, remainder 7. It does have value still. Okay, you will get the answer. It's just not, unfortunately, you know, for some, it's not really taught anymore. As far as I know, haven't seen it around in a while. It's been missing. Okay, I'm going to double check my work here. And I'm going to see if I'm correct. Okay, and of course, if I'm correct, then it will be the dividend. So let's see. 11,685 times 8 plus 7 equals 93,487. Okay. So that's basically the gist on the standard division algorithm. I'll do one more example. And of course, there are so many different videos out there where you can watch, you know, with the fancy technology and the editing and all that stuff, okay? That'll help you with the long division. I want to try a number that is, maybe I'll give myself a divisor that's not too difficult. Okay, and I'll give myself a dividend that's more challenging. So let's say 456,750. If you notice, I just go for it. I just throw numbers out there, no idea, right off the top of my head. It's like freestyle math. And if I make a mistake, I keep it. I'm not going to re-record. All right. So now, 250 obviously can't go into 44 or 45, but it can go into 456. Okay. One time, right? 1 times 250 is 250. Subtract that, I get 206. Drop my 7 down. Now I'm in the thousands place, okay? I know that 4 times 250 will give me 1,000, so therefore 8 times 250 will give me 2,000. Subtract that and get 67. Drop down my 5 here. I know that 250 times 2 is 500. Subtract 675 minus 500. Get 175. I can't subtract in it. Drop my 0. Now it's 1,750. And I know that's going to be 7 because it's 250 less than 8 times 250, which was 2,000. 7 times 250 equals 1,750. And I have absolutely no remainders. Okay? All right, so let's see if that's correct. Okay, remember what we do. In this case, we don't have to add a remainder because there is none. So just add your divisor times your quotient and see if it equals your dividend. Okay. So 250 times 1,827 equals, ta-da, 456,750. And of course, that was what's called an inverse operation, where you're doing the opposite. Okay. My students know this as the turnaround rule. This was an advanced way, kids, to do the turnaround rule. All right. So once again, there's a lot of values still in long division. Okay, look at how big these numbers are that we're dividing, and you get the right answer. Okay, so that's definitely going to be a pro for us. So let's go ahead and look at our chart here, and we will think about the pros and the cons of the standard division algorithm. Okay. Standard division algorithm, otherwise known as long division. Okay. Pros. Cons. What's good about it? What's not, in my opinion? Okay, so in my opinion, number one is you can divide big numbers and get the answer right. Correct, rather. Cons, okay, is that you're not thinking about the value of the numbers. It's just a procedure to get the answer. Pros, okay, and I have to admit this, I thought it was kind of fun. It was like nostalgia for me because this is how I learned as a kid. I didn't know any other ways. Okay, a con is that, okay, you're just working with your basic facts for multiplication. Okay. No, that's not quite true because I was working with higher numbers and multiplying, so that's not quite true. A con does not promote math fluency, I don't think, in my opinion. If you don't have a whiteboard and a dry erase marker or a pencil and paper, you're not going to be able to do it mentally, in my opinion. Maybe somebody can, but not me. Okay, and ultimately, I don't know a lot of people that walk around with a whiteboard and a dry erase marker. I know I don't. Okay? All right, so that concludes Mr. M's instruction with the 4 operations of addition, subtraction, multiplication, and division. I hope you've enjoyed those lessons, And I hope that you, of course, practice. All right, that's going to be the most important part. And I hope you've enjoyed it, and thank you for spending time with me and working so hard to learn as much as possible. Good night.